let's get started with the webinar. But first, I would like to recommend you to watch our previous webinar about project management in the life science industry, because the subjects, they are connected in a certain way. So if you haven't the opportunity to check yet, please consider doing it. And you can find the video on our YouTube channel. So let's start talking about BIM management in the life science industry. And for today, we have a very simple agenda. So we'll start talking about Nordika. Who is Nordika? Also, I will give you an introduction about myself, and then we'll start discussing BIM and the main concepts of it, and the challenge that we have on the life science industry, and how can BIM help. And of course, in the end, we'll have a briefly conclusion. So about Nordika, we are a consulting company, and we are focused on the life science industry. We have two operations, one in Brazil and one here in Denmark. We have all disciplines in-house, and we have a quality system certified by ISO. Our project portfolios consist of 50% of pharma and biotech projects, 30% cosmetics, and 20% food and beverage. We are very proud to say also that we have been recognized by ISP Brazil 7 times as the best company, as the company of the year, and 5 times we have won 5 times on the Sindus Pharma Quality Award in the category of projects and facilities. And we are very happy about these achievements. So about our history, we start our operations in 2012 as NNE Pharmaplan in Brazil. And in 2015, we became an independent company as a spin-off of NNE Pharmaplan, and our focus was in the Latin American marketing. In 2022, we started our operations here in Copenhagen, Denmark. About our CEO, Ole, he's the owner and the CEO of Nordika, and he's a Danish naval engineering with more than 35 years of experience in project life sciences, in life science projects, sorry. And about our main services, today we can support our clients in the engineering design, automations and systems integration, and the commissioning, quality and validation, and as well in the project and construction management. So a bit about myself now. I am an architect specialized in BIM management. I have more than 80 years of experience, and the main clients that I had the opportunity to work with was Nordisk, Abbott, and Bayer. And currently, I'm working as head of BIM in Nordika, Denmark. So let's start talking about BIM. And before, first things first, I would like to define what it's BIM. We can say that BIM is the foundation of the digital transformation, the architecture, engineering, and construction industry. But what does exactly it means? And to answer this question, I would like to bring here two different definitions from two different organizations. The first one you can see on the screen is from DSE UK, and they say that BIM is the management of information through the whole life cycle of a built asset. And the second one, it's from Bing Dictionary. You cannot see on the screen, but I'll tell you. And the Bing Dictionary, they say that Bing is the set of technologies, process, and policies that enables multiple stakeholders to collaborate in the design, construction, and operation phase of a facility, of course, in a virtual space. So considering these two definitions, and in here it's my personal opinion. So considering this, we can say that the main benefit of BIM is increasing our decision-making capacity by using a reliable data. So in the end, BIM, it's all about data. And for a better understand, I would like to show you the diagram that we have in the bottom of the presentation. And this is the relation of time and costs and efforts. And and first, I would like to ask you to pay attention on the blue line and the red line. So the blue line is the ability that we have to impact the costs and performances and performance, and the red line is the cost of a design change. So we can see in here that in the early stages of the life cycle of a built asset, we have a very high ability to impact costs and performance by making a design change. But as the design progresses to the next phase, this started to change, and then in the phase of the documentation, we have a breakpoint where we can see that by making a design change, we have a really high cost. So having this in mind, we need to pay attention now in the red line, no, sorry, in the green line. So the BIM workflow. And in here, we can understand that by using the BIM workflow, we are predicting things for the early stages. So we'll start seeing that we'll start making decisions in the early stages. And by doing this, we have a high ability to impact the costs and performance. And of course that this applies for all kinds of industries, not only for the life science industry. And but then we need to start talk specific about the life science industry. And first, I would like to tell you what we consider as the life science industry. And I have in here on my notes an explanation that we consider the life science industry all business and organizations that are involved on research, development, and manufacture of products that improve human or animal health. And of course, that this includes like the pharmaceutical, the biotech, and the healthcare related technologies. And why we can say that the life science projects, why is it more complex than the others? And we can say that it's because of the combination of the regulatory requirements, the technology, and the operational requirements. And in this presentation, we are going to go through the main challenges in the life science industry, and then we'll try to explain how can BIM help us on this. So the first challenge that I have listed in here, it's about regulatory requirements. And of course that the life science facilities, they must comply with the building and the local requirements, but also they need to follow the requirements set by agencies, FDA, EMA, and GMP. And all these requirements, they will define the what we need to follow in that time, from the clean rooms classifications to the materials that we are allowed to use in the surfaces. And how can BIM help in here? A good example of it, and is the first image, it's in the HVAC discipline, that by adding in the 3D elements the information that is needed for making the CFD analysis, we can simulate and analyze the airflow, temperature distribution, and ventilation efficiency in our plant. And of course, this will ensure the compliance while we are reducing costs. And the second example that I have in here, and this is something that I would say that it's a classic, because in all projects we need to check if we are following the accessibility requirements. So we can test by using a specific software. We can easily test if our escape routes is following the measurements that is required, if all doors they have the measurements in accordance, and also about fire and ATEX zones, we can create rules to asking the software to report to us if all elements inside of these areas they are following the specifications that it's needed. And another thing that I would say that it's not as usual as the two that I have showed in here, it's about we need to think about the BIM model a bit different in here, because once you understand that you have data, not only a 3D model, you understand that you can manage your design not only in the 3D but also like in schedules. And in the third image that we have in here, it's a simple example just to represent what it's possible. So we had a PW pipe, and by the client requirements, we need to make sure that all the pipes in the systems are following the slope required. So we just created an easy rule inside of the design software, asking the software to report any pipe that the slope is greater than the 30% allowed. And as you probably know, the schedule and the 3D model, they are made from the same data, so they are connected, and they will be adjusted out simultaneously while you are changing your design. So when the design it's making a new route, for example, the software will be reporting this simultaneously. So it's pretty easy to design identify if they are in compliance with this or not. And next challenge, so I will just take a bit of water. So the next challenge that we have in here, it's about space management and multidisciplinary coordination. So we know that the life science facilities, they are composed by high complex systems like HVAC, process piping, specialized equipment, and all of these requires a spatial coordination. And we in Nordika, we understand that in order to have multidisciplinary coordination process, smoothly process, we need to start in the early stages. So once we have the architecture, structure, and mechanical layout decided, we need to start planning how we are going to use the space. So in the image that you can see on the slide, we have a section of a building showing the zones that 8 disciplines can use to place their elements. So, and we call this clash avoidance strategy. Also on the ISO 19650, the BIM ISO, we call this federation strategy, and some companies they call this space management strategy. And that's something that it's interesting, because sometimes we have this feeling that BIM will solve all the issues in your design, and that's not true, because you need to have a strong engineering process behind of it. And once you have planned your space and how and set your clash avoidance strategy, then you can also start the clash detection process. And I would say that this is one of the most famous BIM benefits. It's you always see this on LinkedIn or a material that people are sharing on internet, but we need to know that we have different types of clash detection. In here, I have listed 2, but we have more. The first one is the hard clash. So when we have 2 different elements in the same space, so they are colliding, and it's not possible to build something like this in the real world. So we need to have a process established in the project to identify these and solve in the design phase instead of solving on the construction phase. The second type is the soft clash, and this one is a bit tricky it's a bit tricky to identify, because we have different ways of doing it. The first one, like I said, we can set rules in our check uh, software, or we can actually model in the 3D. So in the image that we have in here, we have an equipment, and then we have a red box around it. This is the clearance that we need for operate the equipment. So in this way, we can see it'll be like more visual to identify the collisions, but also it'll be easier to test in the software. But it's also possible, like for example, we have this is another class code that is the electrical and the instrumentation cable trace. We need to have a certain distance between these elements, because otherwise they can interfere in the systems. So by informing if your cable tray is for electrical or instrumentation, we can set a rule asking the software to check if we're respecting the distance required. And this is the soft clash. Of course, that some of the design issues, it's not possible to automatize by softwares. So you need to have a schedule for a visual check in your design also. Then we can go for the next challenge, that is scalability. And here I would like to add something also, but first the scalability. So we often need to design our facilities thinking about future expansions. And something that I would like to add, it's also about reforms or changing equipment. It always happens, so you need to make a shutdown in your plant or this kind of activity. And having your data organized in a 3D model will enables you to have a reliable information to share with your engineering companies or with your contractors. Because and on the graphic that we see on the screen, we can see that in the traditional information flow, we lost information every time that we go from face to face. So you are losing information, and it means that if you are going to start a new project or an expansion, your engineering company will need to expend some time by making the surveys to have the enough information to make their job. So in the other hand, the BIM workflow, so the purple line, it's a more continuous information flow. It means that we are not losing information, we are just increasing it while we are progressing to the next phases. Then then we have risk management. And we know that the cost of a life science building, it's very high, as is the value that it generates. So the construction delays or the bottlenecks or errors and the operation must be avoided. And how can BIM help in here is that we can predict the activities in the 3D simulation. So you can simulate your operation process in the 3D model, and you can identify if you need to make any design adjustment in the early stages. And we always need to keep in mind that if it's in the early stage, then it costs less for you. And about the construction, it's also possible to simulate the construction sequence using the 3D model. And for high complex facilities, it's not possible to plan using only schedules and 2D drawings, because it's a really high risk that you are missing something. So you can use your 3D model for planning the sequence. And again, you need to have a very strong engineering process behind of it. So in Nordika, we advise our clients to use EWP methodology. That is, I'll not try to explain this in the webinar, but it's mainly breaking down your model into small packages, and this way we can plan better. We will have a more reliable source of information for the planning team. And of course, that it's also possible to use VR for the simulation. So, and we use this a lot with our clients, especially the maintenance teams. They usually want to walk around in the plant before it's built, so they can understand how they are going to maintain a valve, or if it's reachable, or this kind of analysis, and then we can use VR for it. The next one, and the last one also, it's about construction control, commissioning, and validation. And we know that this is something this is really time consuming because it requires extensive documentation and the quality assurance. And how can BIM help in here? And how we are doing it in Nordica is that you have your 3D model. The 3D model is your database, but you also have a CDE that it's the common data environmental. So the other kinds of information, so the plans, the documents, photos, checklists, everything, it's placed in the same environmental. And then you can link your commissioning plans with the 3D model. And in the image that we have in here, you can see that we have a color scheme. So we have red elements, blue elements, and green elements. The red ones are the ones that are not constructed yet. The blue ones are the ones that are constructed, but it's missing the construction control process. It haven't going through yet. And then we have the green ones that are the ones that are checked as built and everything. Having this in the same environmental, it will enables you to have better KPIs and control of your projects. And in the video that you can see on the screen, it's also it's a map that we have developed internal, and it's overlapping the 3D model with the real equipment. So, and in this way, we can easily identify if something was built different from the design, and then we can, like you can see, some of the elbows that they are placed in slightly different from the 3D model and so on. So you can identify it better your deviations also. And that's the challenge that I have prepared to present you. And then by conclusion, I would like to just to have a phrase that is BIM can help the life science industry by improving efficiency, ensure compliance, and optimize facilities performance from the design to the operation phase. And so if you have any questions, please raise your hand or send in the chat. Do we have something? Not yet. Let's leave people some time. I think we're very utilizing time, so we can just let the chat open. Okay. So the chat is open for you. Please, if you have any question or would like some clarifications, please ask us. We can see that the microphones, they are not available for everyone, so you need to request and then we can open for you. Otherwise, I would like to thank you all for participating in the webinar. We'll have others. Please check our social medias for the next webinars that will be available. And if you want to watch again, soon this video will be available on our YouTube channel. So thank you very much.